So welcome to today's lecture. Today I'll discuss about state table reduction. Okay, state table reduction. You know what is a state table. So how to reduce or how to minimize the states or how to reduce the state table. For certain analysis, we need a reduced state table. If the state table is reduced like that, we can reduce the number of states. So we will get an optimum state diagram. Okay, always we need a less circuitry, so we need to reduce the states. So what are the steps? First is determine equivalent pair of states. Second, set of equivalent states are established. Third, reduced state table is constructed. So how this state table reduction is obtained with these three steps. So first is determine the equivalent pair of states. So for these things, first we need to know an implication chart. Through implication chart only we can reduce the states. Different methods are there. Here I am discussing about implication chart, how implication chart can be used to reduce the states. So look at here. So here I am giving a state table and it is asked to find out the implication chart and reduce the minimum state table. Okay, first given with the state table. So you know what is a state table. It is having a present state, then next state, output for different inputs. What is the next state? For different inputs, what is the output for a particular present state? So look at here, for this present state A, 0 input, next state is A and output is 0 for 0 input. For present state A, for 1 input, next state is B and output is 0 for 1 input. For this 1 input, output is 0 for the present state A. So this is actually the representation of a state table. So first we need to reduce the state table. Look at in the output diagram, output table. So we have for different states we have same outputs. Okay, so we can reduce the number of states through this implication chart. How this implication chart is constructed. Let's look at that. Okay, this is actually the implication chart. To draw the implication chart, what you have to do is, first, what are the different states? What are the different present states that you have to write in a row and a column? So here the states starts from A and it is end in G. State A, B, C, D, E, F, G. So in order to write this, what you have to do is, first you write the states in row and you write the states in column also. While writing it in the bottom side column, this is in column and these are the different rows and these are the columns. So first you write it in a column A, B, C, D, E, F. Then now after that you write it in a row. So while writing in column, first is A, B, C, D, E, F. Actually our states are from A to G, but in column you have to write A, B, C, D, E, F only, up to F only. And in column you write from B to G. Okay, in rows you write in B to G, in columns you write in A to F. Okay, so it is like this. I am writing A, B, C, D, E, F. Here it is B, C, D, E, F, G. So the column is completed. So now we need to give entries to this column. So how to give that? First look at the column A, okay, and look at the row B. Intersecting A and B, intersecting A and B, this is the column. Column of intersection A and B is that. This is the column, okay. And look at the entries and that column. Okay, this is the present state A and this is present state B. Look at the output. One is 0, 0. For A, output is, for the present state A, for different inputs, what is the output? 0, 0. For present state B, What is the different output? 0 1. So both this, for the state A output is 0 0, for the state B output is 0 1. That means that outputs are different. That is, it is not matched. So there is no correlation between this A and B outputs. So we can put a cross there. We can put a cross there. Why? Because it is not matched. This A and B, their outputs are not matched. So in reducing the state table, first we need to check whether the outputs are equal. If the outputs are equal, then next we will check for the next state. If both the two conditions are satisfied, then we can reduce that table. For example, this A output is 0 0, and for B also output is 0 0. Then we can say A and B are almost equal, and we can reduce this B state. Instead of B state, we can write A state only. By giving A state itself, we can represent the diagram without giving any B state. That is our idea. So our idea is to reduce the number of states which is having same outputs and almost same number of same next state. That we are checking with this implication chart. So we need to check the output first. In first condition, we need to check the output. If the outputs are equal, then we can take it. If the outputs are not equal, we can put a cross mark. So first, this A and B states are outputs are not equal, so we put a cross mark there. Now check for A and C. Now check for the states A and C. What is the state A? 0 0. Sorry, what is the output of state A? 0 0. Output of state C, it is 0 0. So outputs are equal. So now we can give entries to that particular column. AC, intersection AC column. So what are the state for A? For 0 it is A, for C 0 it is F. So you can write like this. This is A, this is C, so intersection is here. So you can write like this, A comma F. Okay, why? Because in state A output is 0 0, state C output 0, so both the states are almost equal. Both the output of the states are almost equal, so we can give entries to that particular column. We need to check the next state, and if that is also equal, then we can reduce the states. That is our idea. So for the state A, for 0 input it is A, here state C 0 input is F, so A comma F we written like that. And now for state B, state A, one input is B, state Z, one input is E, so we can written as B comma E, B comma E. Okay, now we check for A and D, A, D column. So look at A, output is 0 0. Look at D, output is 0 0. So both the outputs are equal, then we can check for next state. For state A 0, it is A only. For state D 0, it is D only. Here same state is repeated, so we don't want to write that AD. Why? Because here it is AD, and again we don't write AD here. Okay, it's already understood that the states are equal. So what is for 1 B, what is for 1 here F, so we can write B comma F. Here we can write B comma F. We don't want to write A comma D, so already we are checking for AD combination, and so for 0 it is the same state, and for here 0, for it is same state. Here also 0, it is the same state. For input 0, same state. So same state means we don't want to write that entries to that particular column. Next is we check for A and E. A and E we checking. A output is 0 0, E output is 0 0, so the outputs are equal. Then we can check for the next state. For A it is 0 input, it is A, 1 input it is B. For here A 0 input A, but for E 0 input is B, so we can write A comma B. For 1 we can write B comma G. Okay, so like that we written. For E it is A comma B, and here it is B comma G. Okay, now for AF combination. Look at AF combination. So A means 0 0, F means 0 1. Outputs are not equal, so we don't want to consider those pairs, so we put a cross mark because the outputs are not equal. Next for AG. So what is AG? 0 0 A, G is 0 0, so outputs are equal. Now check for next state. A 0 0, A 0, it is A G 0, it is a same state. A comma A means A means same state only. So if such a condition happens, we don't want to write it in the column. A comma A we have to write, and both the states are equal, no? So we don't want to write in such conditions. We are not giving any entries to that particular column. So A means no need to write. BF, for one input it is BF, so that we need to write B comma F pairs. Now check for BC. Now check for BC. B it is 0 1, C it is 0 0, not equal, so we can put a cross mark. What about BD? For BD, B it is 0 1, D it is 0 0, not equal, put a cross mark. And what about BE? B it is 0 1, E it is 0 0, so it is not equal, put a cross mark. What about BF? B it is 0 1, F it is 0 1, so the outputs are equal. F is 0 1, outputs are equal. Then check for 0. For 0 it is D, here F 0 it is G. Okay, so we can put a B comma G, D comma G, D comma G. So what is the next step? For 0 it is D comma G, but for 1 it is C comma C. Same C state is repeating, so no need to write. What about BG state? B it is 0 1, G it is 0 0, B 0 1, G it is 0 0, so no need to write, put a cross mark, because outputs are not equal. Now complete the entry like this. Now check for CD. Now check for C 0 0, D 0 0. Now write the combination F comma D comma F and E comma F. Okay, so D comma F and E comma F. Now for CE, C 0 0, E 0 0, same sets. Now let's write the combination F comma G and E comma G. Sorry, B comma EC, no, CE combination means FB and EG. So we can write it as B comma F and E comma G. So now CF 0 0 and 0, CF 0 0 0 1, outputs are not equal, so put a cross mark. And CG 0 0, G is also 0 0, so FA, that is A comma F and E comma F, A comma F, E comma F. Like that you fill up the entire cases, entire columns. So I will put B comma D, DF outputs are not equal, so I put a cross mark. Why? Because D 0 0, F 0 1, outputs are not equal, so I put a cross mark. Like that you fill up the entire tables. So DG, so why I am thinking like this? DG means 0 0 0 0, and for 0 input D is D only, 1 bit it is A, so A comma D, one combination. For 1 input it is FF only, FF same combination, so no need to write. So that's why I am returning AD. Like that you complete the column. And this FG combination, it is cross. So you fill up this entire column. This is the first step. Now the second pass. Now we need to go for second pass. First pass we completed all this. Okay, in second pass we need to again check the combinations. Look at here. First is AC. This is crossed, so no need to check. Next this is AC combination. In AC we have AF entry and BE entry. Then check for first AF entry. Check for AF entry. First check for AF entry. Okay.